Hi everyone, welcome to my Excel data analytics portfolio project. So in this project, I developed the Nexora India employee attrition and workflows analytics dashboard using Microsoft Excel. So the objective of this project is to transform a centralized employee database into meaningful HR insights related to workforce size, employee attrition, tenure, compensation, gender diversity, and function-wise performance. So this workbook follows a structured reporting architecture. First, I created the employee master database, which acts as a single source of truth. Second, as you can see, I've created KPIs, calculation sheet where all major workforce metrics are calculated using formulas such as COUNTIFS, COUNTA, AVERAGEIFS, SUMPRODUCT, IFERROR, and today I'll definitely show you that. Then I have created a function-wise breakdown to compare active headcount, employee exits, attrition, average CTC, and average tenure across different business functions. Finally, I've connected these calculation sheets to an executive level HR dashboard containing 4 KPI cards and 4 analytical charts. So let me begin with employee master database first. Okay, so here, as you can see here, in the employee master data sheet, it actually contains around 80 employee records and acts as a central data source for the entire workbook. Now, this is a raw data sheet, so cells mainly contain employee information rather than formulas. All formulas are maintained separately in the KPI and function-wise breakdown sheets. So the separation is intentional because it keeps raw data, analytical calculations, and visual reporting organized in different layers. Now let me explain the columns, okay? So the first column, as you can see, is the employee ID. It basically is a unique identifier such as EMP1001, EMP1002, and so on. So I use employee ID when calculating the total employee population because it's most reliable field for counting unique employee records. Moving on, there's a name column. The name column stores the employee full name. This field provides descriptive information, but it's not directly used in the KPI calculation, okay? Then moving on to function columns. So function column represents the employee broad business units such as engineering, sales, marketing, operations, HR, finance, and customer success. So this column is especially important because it drives the entire function-wise breakdown and the headcount and attrition charts. So this function column is super important. Remember that. Then there's department. So department column provides a more detailed classification with each function. For example, engineering contains departments such as front-end, mobile, data, DevOps, backend, and QA. Although this dashboard currently analyzes employees at a function level, the same dataset could later support department level reporting. Moving on to designation. The designation column records the employee's job level or role such as associate, analyst, manager, head, director, or VP. This field could be used in future analysis such as job level compensation, seniority distribution, or leadership representation. Moving on to joining date. This column stores the employee's original date of joining. These values are like maintained as actual spreadsheet dates rather than text because they are used in tenure calculations. Moving on to gender, the column contains three categories: male, female, other. Location, the column contains employees' work location, including cities such as Bengaluru, Mumbai, Pune, Hyderabad, Kolkata, Ahmedabad, Delhi NCR, etc. So this data can support future location-wise workforce analysis if you want to do that. And the CTC column stores the employee's annual cost to company in Indian rupees. So it is used to calculate average compensation at both company and function level. Moving on to status, this column contains two standardized values, active and existed. This is one of the most important fields in the workbook because nearly every KPI filter employs using their current employment status. So conditional formatting has also been applied so the active employees appear in green and existing employees appear in red. Okay. So likewise, conditional formatting is applied. Then this exit date is the final column. This remains blank for active employees and contains a valid date for employees who have exited. This data could also be used for time-based attrition analysis when a specific month, quarter, or financial year must be evaluated. This employees master therefore acts as a single source for truth for all calculations that follow. Then moving on, we go to the KPI line sheet. So this sheet converts the raw employee data into measurable workforce indicators. The first section contains 5 headline metrics. That's total headcount, total employees, employees exited, attrition rate, and average tenure. Now let me explain each formula in detail. So as you can see, in total headcount, if I see the formula, it is equals to COUNTIFS. So we have used the COUNTIFS formula here. Employee master, that's the sheet we are referring to. J6 to J85, comma, active. So basically COUNTIFS counts the cell from that meet one or more conditions, right? COUNTIFS counts cell that meet one or more condition. Remember that. First argument, as you can see, is employee master J6 J85. This tells Excel to examine the status column in the employee master sheet. And the second argument is active. This is a condition. So Excel counts only those rows where status values exactly matches active. So I use COUNTIFS instead of COUNTA because COUNTA would count all non-blank records, including employees who have exited. For this KPI, I especially needed the organization's current workforce. That's why I've used COUNTIF, okay? So as you can see, this formula returns around 70 active employees. So the KPI automatically changes whenever an employee status changes from active to exited, or when a new active employee is added. Okay. So I hope you understand why I have not used COUNTA. Because COUNTA is like it counts all non-blank records, including employees who have exited. But we want employees who are active right now, right? That's why we have 70 active employees. That's the total head count. Then we move to total employees, that's active plus exited. Here we have used COUNTA because, as you know, COUNTA counts all non-blank cells within a selected range. So here the formula checks the same way. Employee master A6 A85. So this is basically the employee ID column. I selected employee ID because every valid employee record should have one unique and non-blank ID. Unlike the previous KPI, I do not apply a status condition because I do not see the complete employee population represented in the dataset. So yeah, it's 80 total employees, and yeah, I hope you understand. You see here we have used the employee ID column, and here we have used the status column. Okay, if I go here, I would show you that this is a status column J6. Okay, this is J6 to J85. That's the status column. And for the second one, we have used the employee ID column. That's A6 to A85. Okay, I hope you understand that. Okay, perfect. Moving on, we move on to employees exited. So here we have used COUNTIFS because, as you know, COUNTA calculates all the non-blank columns too. But since we just want to know who is exited, so we again go to status, and this time the condition is exited. The in total headcount it was active, and here it's exited because we want to know how many people have exited, and as you can see, 10 people have exited. Then there comes attrition rate. So as you can see, the formula here is COUNTIFS employee master J6 J85 exited. Then there is a slash, and then COUNTA employee master 86 and 85. So here, as you can see, we have used both the columns A6 and J6, and we have used COUNTIFS and COUNTA at the same time. So as you can see, the numerator is COUNTIFS, right? This returns the number of employees who exited, which is 10, right? So this returns the number of employees who have exited. So basically 10. And this is count A, this one, total employees. This kind of represents the employees population, which is 80. As you can see, the attrition result is 12.5%. The cell is formatted as a percentage, so Excel displays the decimal value as 12.5%. This matrix helps HR monitor employee turnover and identify whether employee exits require further investigation. Now, one important analytical point is that function level percentage should be interpreted together with the underlying headcount. For example, one exit is a small function, can produce a higher percentage even though the absolute number of exit is low. Okay, moving on to average tenure. So this next KPI calculates the average tenure of employees who are currently active. Now, as you can see, we have used the formula is equal to today, parenthesis, minus AVERAGEIFS. And then in parenthesis, in the averages parenthesis, we have employee master F6 to F85 and employee master J6 to J85. So as you know, J6 to J85 is status. That's why we have like kept it like we just want the active employees tenure, average tenure. So the formula combines today's and averages. Now, if you see the first one, averages, is employee master F6 and F85. This contains the joining date that needs to be averaged, right? So the criteria range from employee master J6 to J85 contains employee status, which is the criteria is active, ensures that only active employees are included. So Excel stores data as serial numbers. Therefore, AVERAGEIFS return the average joining date serial number for the active workforce. Why we use today? Parenthesis, it actually returns the current date as another Excel serial number. The formula subtracts the average joining date from today's date. So today, parenthesis minus average joining date. This produces the average number of days employees have been with the organization. And finally, the result is divided by 365.25. Dividing by 365.25 displays days into years and provides a reasonable adjustment for leap years. The results will update automatically each day because the formula contains today. After correcting the missing employee, the display average will be approximately 4.26 years. This formula avoids adding a separate tenure column to the raw data set. Moving on to gender split. As you can see, the female is 24, male is 41, and others is 1, and percent of active users likewise. So I have deliberately filtered by active status because the objective is to understand the composition of the current workforce rather than everyone historically recorded in the database. So the female active employees, as you can see, we have used the formula of COUNTIFS. So as you can see in this formula, we have considered the column G6, G85 and column J6, J85. So there's a gender column and there's a status column. So the first criteria range is gender column, as you can see, and second criteria range is the status column. Now, COUNTIFS counts a record only when both conditions are true. Therefore, the employee must be female and active. The result is 28 active female employees. Same for the male. COUNTIFS has done the same thing. So, structure is identical, but the gender condition changes from female to male. After including the employee omitted by original range, the results become 41 active male employees. And the other is also the same thing. I think it's very, very eminent to know. Moving on to the percentage. So this is the gender percentage of active workforce. Counts are useful, but percentage make it easier to understand how much each category contributes to active workforce. For example, the female percentage formula is C15 by C7, right? Now what is C7? C7 is the head count, okay? And what is C15? C15 is this count, okay? And that's how we get the percentage. So what is this dollar? So basically C15 is like it contains female active filigrant, and $C$7 contains the total active head counts. Now dollar signs make the denominator an absolute reference. This means the reference remains locked to C7 when formula is copied downward for male and others. The same pattern is used for remaining categories. Okay. And yeah, I don't think so I need to show you, but I'll show you still. Okay. This is C16 and this is C7. Okay. It's perfect. Okay, so moving on. So this is a gender diversity percentage. The gender diversity KPI measures active female employee as percentage of total active employees. So the workbook, as you can see, is currently using C15 or KPI C7 because this formula is already on KPI sheet, so it can be simplified to, I can like simplify it to $C and $7. If you want, I can write it and show you. So this is KPIs, right? So what I'll do here is I will just do it $C and $7. Okay, we get the same thing. Okay, there's no changes. I'm just showing you that you can write the formula like that. So corrected result is 40%. This provides management with a quick view of female representation with current workforce. So I would present this as an internal workforce composition measure. Any external benchmark should be separately sourced and contextualized by geography, industry, seniority, and job function. Moving on to tenure distribution. So next section group actives employees into 5 tenure bands: 0 to 1 year, 1 to 3 years, 3 to 5 years, 5 to 10 years, 10 years and above. So for this section, I use a sum product. So COUNTIFS work well when conditions are directly stored in cells. However, tenure is not stored as a separate field in the dataset. It must be first calculated dynamically from joining date. So we use SUMPRODUCT. It allows me to evaluate the status condition and calculated tenure conditions across every employee record without creating a helper column. So yeah, we move on with this. Okay, let me just see what exactly is going on. So first we use SUMPRODUCT, then employee master table, status active, then again we have 3 brackets, today minus employee master table, let's sheet, sorry, F6 F85 divided by 365.25, written equal to 0. Okay, very interesting. Okay, so first one, as you can see, the employee master sheet J6 J85 is equal to active, that's status. This produces an array of true and false values based on employee status. What does this? It produces an array of true and false values based on employee status. Now, second condition, as you can see, calculates tenure and checks whether it's greater than or equal to 0. Now, today, bracket parenthesis minus joining date divided by 365.25, bracket close, greater than equal to 0. So the third condition checks whether tenure is less than 1 year. Now today, parenthesis minus joining date, divided by 365.25, bracket close, less than 1. So the multiplication symbols act like logical AND operators. A row is counted only when status is active. Tenure is at least 0. Tenure is below 1 year. So SUMPRODUCT converts matching true values into 1 and adds them together. Now this formula allows the same structures with different boundaries. It counts, as you can see, this formula is same, okay, with different boundaries, but it kind of counts active employees whose tenure is at least 1 year, but below 3 years, okay? So that's why we have used less than 3 here. You see, we have used less than 1. And I think same will go for this, less than 5, okay? This counts active employee with tenure from 3 years up to, but not including 5 years, right? And 5 years to 10 years. This counts active employers with at least 5 years, but fewer than 10 years of tenure. And 10 years of above, only a lower boundary is needed because there is no upper limit for this category, right? So very interesting formula. Perfect. Moving on to the percentage of active employees. Now, since we have got the count, we would use the percentage formula. We would just do this count divided by the total head count. That's it. We have done the same thing. Okay. Perfect. So yeah, let's move on to the function-wise breakdown. So the function-wise breakdown compares active headcount, exited employees, attrition percentage, average CTC, and average tenure. The formulas shown for engineering are copied to the remaining rows using the relevant function name. Now, you see, first is the function-wise headcount, right? So what formula we have used here? We have used COUNTIFS, and we have used the sheet data again, and C6, C85. I think this is the first criteria is engineering. The second criteria is status column, and second criteria is active. Okay. First criteria range is like I think the function column. Okay. Therefore, Excel counts only employees who belong to engineering and are currently active. This reduces the engineering active headcount. Same goes with sales. Okay. Then, yep. Since why we are using C, you will see. Okay. So we use C because you see C has functions. And that's why we use C. It's as simple as that. And we are using COUNTIFS because COUNTIFS normally only calculates what exactly is given. Like the employees should have engineering and should be active. So that's why we use COUNTIFS and we mention the sheets and the columns. Okay. So I hope we are all clear with COUNTIFS. Moving on, again, we have used COUNTIFS where, you know, you can see the function remains engineering but the status remains exited. So yeah. And the attrition, in attrition, we have used IFERROR before COUNTIFS. So first we have just used normal COUNTIFS. Think about it like that, where we have used the function, we have used the status exited, and then we have divided the COUNTIFS with the sheet where we have used the function again and engineering. And we have used IFERROR. Now, why we have used IFERROR? See, the whole formula is basically wrapped in IFERROR, right? This is like a defensive formula. So if a function has no employee records, the denominator would be 0 and Excel would normally return division, like error, right? Hashtag division.0. So IFERROR replaces the error with 0, keeping the report clean and usable. That's why we use IFERROR. Okay. Yeah, I think it's very like you can say numerator count exited engineering employees, right? The numerator count, what it does, it counts exited engineering employee. Okay. The first countif function is like that, right? It is counting the exited engineering employees. And the denominator counts all engineering employees regardless of the status. So Excel divides exited employees by complete engineering population. And for that, we wrap this in IFERROR so that it doesn't give error. Instead of that, it gives 0. Okay. So as you can see, given below, that's how we get the attrition rate. And conditional formatting is applied to the percentage. Green is applied to below 8%, yellow 8 to 15%, red is above 15%. Now this helps user quickly identify high attrition functions quickly, okay? However, percentages should always be interpreted with headcount. HR shows a high percentage because the function is small, so a single exit has large proportional effects. Perfect. I think we have used the same thing for average CTT. We have used the IFERROR and AVERAGEIFS. So as you can see, first we have used the sheet and the column I6, I8, which contains annual CTC value. So the first condition selects the engineering employees. Second condition includes only employees whose status is active, right? And I'm sorry, I'm showing you a different. So yeah, first condition, as you can see, is engineering employees. Second condition is the status should be active. Therefore, the formula calculates the average CTC of current engineering workforce. So that's why it's like averaging the current CTC of the average engineering workforce. Okay. If error returns 0 if no matching employees are found. So yeah, that's why we use that. And moving on to average tenure, we have again used IFERROR, but we have used today minus AVERAGEIFS here. So AVERAGEIFS first calculate the average joining date of active engineering employees. So the criteria are function equals engineering, status equals active. So today, then subtracts that after joining date to determine average service days. So dividing by 365.25 converts the results into year. Finally, if error returns 0, if there are no active employees for a function. So yeah, I think it was pretty like it's simple. Like it's the same like we have used the averages for average CTC, just that it's been minus by today and we have divided it by 365.25. Okay, so yeah, I think it's so why we divide by 365.25, because convert the result into years, and today then subtracts the average joining date to determine average service days, right? And if error, why we use that? Because it wraps the whole formula. It returns 0 if there are no active employees for a function. Okay, I hope it's clear. Perfect. So let's move on to the HR dashboard. So, okay. After completing the calculations, I connected the final metrics to the HR dashboard. So the dashboard does not repeat the complete calculation logic. Instead, it references the already validated KPI cells. As you can see, the total headcount card by function. So this kind of displays the active employees. Okay. We have used the formula KPI C7. We have used from the data sheet, we have used C7 from KPI's data sheet. Okay. Then the average tenure card you can see is 12.5%. Average tenure is 4.26%. Current diversity is 40%. We have all done it in the KPI sheet. We have just in a display format, so that it's very easy to understand. These are the dashboard charts. Now, headcount by function. The first chart shows active headcount by function. As you can see here, engineering is the largest function, followed by operations. Then this gives management a quick understanding of where the workforce is concentrated and can support resource planning, budgeting, and workforce capacity decisions. So after correcting the omitted employee, operations will increase by 1 active employee. Remember that. So second chart is attrition percent by function. This kind of compares the attrition across functions. As you can see, HR has the highest attrition, that's 33.3%. But you see, this must be interpreted carefully because HR has a very small employee base. One exit therefore creates a relatively high percentage. Customer success and engineering also show notable attrition, right? It's 16.7% and it's around 15.8%. And operation and finance show around 0 exits within the current data set, right? So this chart is useful for identifying where deeper retention analysis may be required, but percentage should always be reviewed together with absolute exit counts. Moving on, tenure distribution chart. So this distribution chart, group actives employ. This actually shows groups active employees by length of service. It shows where the organization has high proportion of recent hires, a strong mid tenure workforce, a significant number of long serving employees. Okay, so the current concentration is primarily within the mid tenure ranges, indicating that considerable share of employees have moved beyond the initial onboarding stages and possesses established organizational knowledge. Moving on to gender split table. So male is split into 41 and female is 28. So this chart allows leadership to review workforce represents quickly rather than interpreting only raw employee counts. So there's more. As you can see, the engineering active headcount is 32, and yeah, there's so basically this is used for the charts which I have made. Okay. Anyway, to summarize this project kind of demonstrates how a structured employee database can be transformed into meaningful HR insights using Microsoft Excel. The workbook follows a clear analytical flow. Raw employee data is maintained in employee master. Okay, here. Then the KPI sheet calculates organization level metrics. The function-wise breakdown provides detailed comparisons across business functions. And finally, the HR dashboard presents those results through executive KPI cards and charts. So throughout this workbook, I have used COUNTIFS for conditional employee counts, COUNTA for complete employee population, AVERAGEIFS for filtered compensation and joining date average, today for dynamic tenure calculation, SUMPRODUCT for calculated tenure bands, and IFERROR for defensive error handling. And we have also used direct cell references for connecting the calculation sheets to the dashboard. Okay, so I hope you get to learn a lot from this project. Thank you so much for watching.